So now we have to discuss the fourth and the last topic for particulate nature of matter. So in the previous videos you would have seen that we have already discussed the first three topics: solid, liquid and gas, their different characteristics, kinetic theory of matter, its different attributes, and third was change of state of matter under different set of conditions, right? So the fourth and a very small topic, but it is very important, right? In alternative to practical, MCQ, practical paper as well as your structure paper, you can get questions from it. This is very small topic but really important, right? Sometimes they give you some experimental conditions and based on that they ask questions pertaining to that, right? So we have to be very focused, we have to pay attention on each and every word of this topic, right? So the last topic, that is diffusion, evidence for moving particles, right? So the last topic, diffusion, evidence for moving particles, right? What is diffusion? So I'll give you many examples for it. Just think a bit. What is diffusion? Diffuse. In biology also you will study diffusion, and there's one more process similar to like osmosis, but it is kind of similar, but we are not discussing about that. Some students may get confused, kids in biology also. The concept is same but the application is different, right? So diffusion is the movement of particles from a place of higher concentration to a place of lower concentration. That is called diffusion, right? Now direct question, like sometimes they ask what is diffusion, they will give you experimental setup, they will ask why it is happening, so you should know it is happening because of diffusion. Sometimes some different compounds or substances will be given, which one will have faster diffusion and why. So we should have the answers of all these questions. So after this video I hope you will be able to answer all these questions. So let's see. Diffusion, it is a process of movement of particles from a region of or a place of. So it is a process of movement of particles from a region of high concentration or higher concentration to lower concentration, right? So where the concentration is higher, the particles will go to the other side where the concentration is lower. So as we have discussed in the previous video, if I spray perfume in one corner of a room, it will slowly move to every corner of the room and we can feel the fragrance. So what is behind it? The phenomena behind it is diffusion, because if I spray perfume in one corner of the room, it means the concentration of particles are higher in this region. Feel the fragrance everywhere. It means particles have diffused from this place of higher concentration to everywhere where there was low concentration or no concentration. So it will continue to happen till there is uniform distribution of particles, right? So now next see. So next is, let's have some examples that you can see or you can find in your papers. Suppose if you take few crystals of, suppose you have taken a beaker half filled with water, suppose you have put few crystals of say KMnO4. Everybody knows KMnO4, purple color crystals, okay? So in the beginning the higher concentration is here. So after some time, or if we slightly shake it, after some time we will feel that the water will turn pink or purple, and it will be uniformly purple. It's not like we say that it is dark purple here, then less purple here, more purple here. No, it will be uniformly colored everywhere. It means particles diffused from a place of higher concentration to everywhere where there is no concentration or low concentration. So we don't write no concentration, we say low concentration, right? So that's why we call it diffusion. Diffuse from high to low, always, right? So let's take other example. This example you will see in many of your practical or alternative to practical papers. So these are two containers, maybe two measuring cylinders or two containers, okay, right? So say in one region there is only air, or maybe there is some liquid, okay. So I say in the first part there is only air, and here you have filled bromine gas. Bromine gas is reddish brown. So in the beginning, the upper half containing air, maybe containing oxygen and other gases which are colorless, and here say I say that these big circles, say I'm representing these big circles as colored bromine and these small dots as colorless gas. So if you leave this setup for some time, say 2-3 minutes, what will you observe? The next setup will be so what I have done is, I have taken one measuring cylinder or maybe one container containing bromine and the other container containing air. I have inverted one container over another, or one measuring cylinder over another. So after some time what I have seen is, here the concentration of bromine is more. It will diffuse to the place of low concentration, and after some time you will see the bromine molecules are diffused equally everywhere in both the containers, and similarly air particles are also diffused to both the containers equally. So diffusion will continue to take place till there is uniform or equidistribution of all the particles, right? There is one more very important for your practical or alternative to practical, right, and as well as your other two papers. There is some experiment, a very small experiment, so I'll explain you here, right? Take a note of it, it's really important. Okay, let's see. So take a glass tube. Now take a cotton or cotton wool soaked in ammonia. Fix it or plug in to the one side of glass tube. On the other side, take another cotton wool soaked in HCl. So this is the cotton wool soaked in ammonia. This is the cotton wool soaked in HCl, right? Now both are in the gas form. HCl is also in the gas form. You're not taking liquid, and your ammonia is also in the gas form. Now what will happen? The gases will diffuse. So here there is higher concentration of ammonia, here there is higher concentration of HCl. Now ammonia particles will diffuse from here and the HCl particles will diffuse from here, right? And when these two mix up, see what will happen. So if ammonia and HCl, because ammonia particles are moving from left to right and HCl particles are moving from right to left, as these two comes in contact, you will get a salt that's called ammonium chloride salt. Okay, now there is a very important point to be noted here. First thing, gases. We know that diffusion is what? Movement. As we have seen now, we have discussed already a lot of times, that movement is faster if there is more energy, right? So if we want to do the diffusion faster, if we want to see the result faster, we have to increase temperature. So suppose there are two experimental setups given in front of you. You are doing the same thing at 10 degree, then 20 degree, then 50 degree, then 100 degree. Then 100 degree diffusion will be fastest. Okay, so diffusion depends upon temperature. So higher the temperature, higher is the diffusion. Always think it. You will get many questions based on this application. So for diffusion, always very important, higher the temperature, higher is diffusion. Second, very important point. Next, diffusion is depending upon the size and mass also. Smaller the particles, faster the movement. We have studied in kinetic theory of matter. So now you must be able to recollect all the information that I have been studying, giving you different points and concepts, that if there are smaller particles, lighter particles, diffusion is faster. Heavy particles, diffusion is slower. So lighter particle diffuse faster. Lighter particles diffuse faster. So now why I'm explaining you all this, interrupting this concept. Now see, in this case, ammonia, if I say it's lighter or heavy, how will I come to know? Suppose I say that I have a block made up of substance A, I have a block made up of substance B, or maybe one substance made up of some molecules and B made up of some molecules. Then I have to take the weight maybe on a weighing machine, right? But here there is one other way, easy way, where we cannot measure which one is heavy or lighter. And in diffusion, solids at least, we know that solid particles are moving very less, right? Or in case of solids only we can measure the weight. Liquids also, but the container weight will also come. So let's not confuse much. So if we are saying lighter particles diffuse faster, it means, let's take the mass. Nitrogen, we know the atomic mass is 14, and hydrogen, we know the atomic mass is 1. So the total mass is 17. Similarly here, hydrogen mass is 1, chlorine mass is 35.5. So the total mass is 36.5. So out of these two, which one is lighter? Ammonia is lighter, right? So if I say this is the center point for this glass tube, ammonia particles, as they are lighter, they will diffuse faster. And in the same time, suppose I am noticing the result, say after 2 minutes or after 1 minute. So ammonia is lighter, it will diffuse faster, and HCl, they are heavy, they will diffuse slower. So sometimes they ask question, so if you get ammonium chloride, it will be a solid deposition because it is solid, right? So where it will be closer? To which molecule, here, or to which side of the glass tube it will be closer? Because ammonia molecules will diffuse faster, so in the meantime it will cover this distance, ammonia molecules will cover more distance, right? So we will see that the deposition of ammonium chloride will be closer to HCl because these molecules will diffuse faster. The reason behind it is, first of all, why it is happening? Because of diffusion. Second, why it is closer to this side of the glass tube or closer to HCl? Because it is depending upon the size, right, and as well as the mass. So lighter the particles, they will diffuse faster, right? Now we know that ammonia particles are lighter because their mass we have calculated already in terms of atomic mass, so they will diffuse faster and you will get a ring of ammonium chloride closer to HCl, right? So with this, what do we understood? That affects your diffusion. One is temperature. If you increase temperature, diffusion is faster. If you increase the weight, diffusion is slower, right? One more thing, if we compare solid, liquid and gases, gases have the fastest rate of diffusion as compared to solid and liquid. Solid diffusion is not there, it needs some, suppose say dust particles. Dust particles are going one place to another, maybe suppose there's a heap of dust, then air is taking them to one place to another. They cannot move on their own. Suppose I say there's a heap of dust. A strong wind is coming that will take dust from this place of higher concentration to a place of lower concentration. Air is used as a medium. So I gave you example for your, say, bromine liquid or bromine gas. Liquid also we can take for bromine, but in the previous case we took example for your gas. Suppose let's take example for liquid. I gave you example for KMnO4 in liquid. Suppose we have KMnO4 in liquid. KMnO4 is diffusing, again it is solid. We saw that KMnO4 was at the bottom of container, you put them there, but it is diffusing to every portion, to everywhere, wherever is the volume of liquid, because now liquid is being used as a medium. So if solid particles are diffusing, they have to use a medium. Maybe they are using air as a medium, maybe they are using liquid as a medium. They themselves cannot move, but gases, they themselves can move, and diffusion is fastest. Similarly, liquids, their diffusion is slower. Suppose I have liquid here, it will flow from this place to another, but slower as compared to gases, right? Now, next is called intimate mixing. Intimate mixing means if you want to mix liquid and gases together. Okay, there is one liquid, one gas, and liquid is diffusing into gas, or gas is being diffused into liquid, right? This is called intimate mixing. Bonding, they are coming towards each other. We know that gas particles have a lot of space between them. Liquid particles also have a lot of space between them. So they move into the spaces of each other, and it's called intimate mixing. For example, so anything to be noted here, you can have a note. Okay, intimate mixing. Now, intimate mixing or intimate diffusion. So suppose this is a container containing water. Suppose you are diffusing oxygen gas to it. Now we know that gas particles have space between them, as well as say liquid particles have space between them. So these gas particles will diffuse into the space between liquid. Liquid particle can diffuse into the space between gas particles. This is called intimate mixing, intimate diffusion. It will continue to happen till there is uniform concentration or uniform arrangement for both gas and liquids. Next. So with this diffusion is over, there is one small point and small topic left in this chapter and this topic now, that is called Brownian movement. There is a scientist known as Robert Brown who gave this concept. He said that particles move continuously, randomly in all directions, but still he gave a generalization that the zigzag movement of particles is known as Brownian movement. So Brownian movement is zigzag movement of particles, right? So what he did was, he did a small activity. He takes some pollen grains and he spread it over water. He took some pollen grains, he spreaded it over surface of water. So will they have any definite arrangement? No. They will randomly flick over each other, collide with each other, and the distribution will be something like that. This is called zigzag arrangement. So what was the cause of this arrangement? Right? See, the particles, if they are very small, they will move faster. We know that. We have studied it a lot of times, that smaller particles will move faster. Now, why they are moving faster and why is this random distribution? So now there are two types of particles. One which are visible. Suppose I pour some pollen grains over the surface of water. Now water molecules I cannot see. They are very small. I cannot see with my naked eyes. Pollens, they are also very small, but still I can see them, right? So now water molecules, they are invisible. They are colliding with visible pollen grains, striking them continuously. Because of that collision, the particles showing this zigzag random movement. This is called Brownian movement, because of smaller, faster moving particles which are continuously being collided by invisible particles. This is called Brownian movement, the zigzag movement. Okay, so the cause of this movement is smaller, faster, and, or let's say invisible first. Smaller, invisible, and faster moving particles collide with visible smaller particles with great energy or with high energy, resulting in random point. So this we can see, they are randomly going here and there. The cause behind is the particles which you cannot see, they are giving them a push, a collision, which are very small, that cannot be seen. So with this topic, we have successfully finished all the 4 sections of chapter 1, particulate nature of matter. I hope I have cleared all your doubts, and this information will help you to solve most of the questions in all of the 3 papers. So all the very best for all your upcoming exams, and catch you soon with the 2nd unit or with the other important unit of IGCSE chemistry. Till then, have fun, have a wonderful time. Thank you. Bye-bye.